We'll be hearing from Jonathan Brandenburg, and he's the Assistant VP of Engineering working on the Fox Plus program. We'll hear from him, and Jonathan, are you ready? All right. Please give him a warm welcome. Jonathan.
All right, welcome me. Everybody, are you ready for me? We have some sidebar conversations. Shall we finish those up and then we can continue? All right, because that's the kind of person I am. Good afternoon. I'm back at it again. I'm here to talk to a little bit about the AMSAT programs and the Fox Plus program. And I have the exciting opportunity, being assistant to the vice president of engineering, as he likes to call me, to work on a variety of tasks as I volunteered to take on the AMSAT program and volunteered to take on Fox Plus. So I'm going to be covering a lot of different projects at a fairly thin level, but I will be pausing frequently to answer as many questions as I can and deferring as many questions as I can't. We're in slideshow mode now.
Yeah, and I'll put it on here.
All right, thank you. That works. So Jerry already talked a lot about the deployable solar panels and the 3U structure as being part of Golf T and the golf program in general. So I'm not going to repeat most of what he said. But I do want to point out this is an AMSAT project, and as he said, this is primarily an AMSAT project because we're using this as an opportunity to really start pushing our open source techniques, our open source processes, so that we could share this as openly with the community and the world as we could. So that's why you'll find it here. We've had some really good progress on the 3U structure. Mr. Tom Karnauskas has put a great deal of effort into mechanical models of the 3U structure. One of the big achievements, and I do really consider it a big achievement, is that we as AMSAT have acquired and begun to standardize on some modeling software and providing the tools to our volunteers. So we're not necessarily always requiring our volunteers to bring their own tools to work. In certain circumstances, we're able to help with that, and that's the case with the Inventor modeling software. As part of that, you saw the picture, but now I hold the physical 3D printed model. Mr. Tom Karnauskas has printed a very nice 3D model of half of the Golf T satellite. This is the half that has the reaction wheels and the ADCS system, the batteries, the MPPT board, and an interface board there in the middle. So these are the half of the satellite that controls the power and the attitude. I'm going to go ahead and step out of frame to hand this around real quick, just so you can look at it if you want. You'll recognize reaction wheels. And I'm back. So Tom has been working very closely with Dwayne Moberg on the deployable solar panels. Now, having said Dwayne's name, I also want to recognize Vincent. Vincent was a volunteer, and he's re-engaging now that life is allowing him to do so. They're both making good progress on the deployable solar panels. The key here on the deployable solar panels is the primary challenge is how do you pack in 3 layers of solar cells on backplanes into the pockets on the outside of a CubeSat, and that's been a real challenge. So you have to get each cell and all of the little connectors, the little hooky thingies, that's a technical term, hooky thingies, that attach the cells to the PCBs as thin as possible. You still have to have cover glass to protect the cells. And then most importantly, and this has always been the real challenge here, is you need a hinging mechanism and a flexible cabling mechanism to go past the joints. And Dwayne has selected some preliminary hardware for hinges and has started working on the cabling to go around those hinges. So I'm actually very excited by the progress here. I hope the next time we talk, I'll be showing you physical engineering prototypes, maybe is what I'll call them, of both the 3U frame and the solar cells the next time we have this opportunity to meet. I said I'm going to pause frequently to answer questions. This is one of those times. Do we have any questions that I could possibly answer with that brief overview of the solar panels and the 3U structure? Okay, that's okay. That's okay. My feelings aren't hurt. All right, moving on. We do have a lot of AMSAT programs and AMSAT projects, I should say projects. And I want to remind again, AMSAT projects are basically research and development projects. They're opportunities to investigate a technology that we expect and plan to fly on an unspecified future mission. Now, admittedly, the solar panels and the frame that I just talked about were a little odd because we do have a designated mission, but I really think of them as being open source projects with our first customer being golf. These, on the other hand, are really somewhat open-ended in the sense that we don't yet have specified payloads or specified satellites that they'll play on. So I'm going to talk about each of these individually. Starting with the top one, a slow scan TV payload. We have an initiative with Frank Karnauskas, who I think has just stepped out of the room. One of his opportunities, one of the things he pursues is the engagement of youth, like youth type initiatives, and he has recognized or specified that there's a lot of interest in folks receiving pictures from space. Even if they're not live pictures, just receiving pictures from space like you might find on the ISS. So to that end, one of the things that Frank has chartered his brethren in engineering to do is to build a slow scan TV payload. Our progress on that to date has been driven mostly by Will, our volunteer here on the third row. And his primary focus right now is really taking the slow scan TV software that we've really had some good success with on the CubeSat simulator, and taking that and porting it to our flight platform, specifically the TMS 570. So it's the first step down a path of getting a slow scan TV payload by getting the software running on the platform that we actually fly. The radios, PAs, and the filters and all that's a little bit unknown. I think at the moment I've sort of suggested that we just use a D to A to just pump a pin with the necessary modulated signal for slow scan TV just to get something into the ether. So more of a bit banging approach than anything scientific at this point. But that's because we're focusing on the algorithm. Pause. Questions? Yes, Bill. We don't have a mic. We do have a mic.
Could that SSTV payload be combined with a PACSAT payload?
Could that SSTV payload be combined? And I'm still repeating the question even though you have a mic. Yes, there's no reason it could not, in fact. There's obviously some integration points. You're using the AX5043 for the radio chip for the moment. We've struggled a little bit figuring out how to pump FM modulated audio through that, but I think it can be done on the AX5043. But we haven't driven down that far yet. But could we use yours? The answer is very plausibly. Moving on. SDR-B, formerly called SDR Plan B, we talked about that earlier. Ray Roberge and Rich Gopstein have been working on the SDR-B. Ray's been working primarily on the PCB layout and design and the multi-layer board routing. Rich has been really starting on the Linux aspects of that. Again, as Jerry noted, that's an E310 replacement in a lot of ways. That's in a CubeSat footprint format, which will make it give us a microwave payload that will be much more convenient to fly in a CubeSat than what we're currently flying in the commercial board. I'm going to move a little quicker and then maybe hold some questions, but feel free. The FM transponder is an open, kind of a green field that I just kind of threw out there. Andrew Robinson was here. I think I see him over there as my engineering volunteer that's been taking lead on that. I left this one relatively green field when I said, I need a new FM transponder. And I stopped there. I didn't specify that we wanted to rebuild the Fox one. I didn't specify that I wanted discrete. I didn't specify that I wanted SDR. I was going to leave that up to the volunteer to pursue something of technical challenge and interest. It looks like we're heading down the SDR path right now, but there's still questions to be answered even there that Andrew is currently doing a trade study on what is the initial prototype platform going to look like for development. And I do specify prototype at that point. So we are starting to make progress on that, but it's in the early stages for sure. I will not talk much about PACSAT because I think we have a whole PACSAT presentation coming up here, but that is another project under the Ascent umbrella. And this also is a good example of a fairly independent project. We have a very dedicated, very talented, and very, what's the right term, excited, I guess. I'm not using the quite right word there, but team that's really engaged on the PACSAT project, and they're enthused about it, and they're really bought into it. So they've been running independently. I provide some oversight as AVPE. I exert budget control mostly, but the technical approaches are largely theirs to solve. So very exciting as well. We'll keep going for a few minutes. Can I go long, or am I stopping when I stop? I've got a little more time. So at that point, I am going to pause and answer questions, but I will not answer questions about PACSAT because I would like Bill and his team to answer those when they present next, and they are next. So do we have any questions? Or oftentimes in this room, I get more suggestions than I have questions, and that's okay. Any questions about SDRB or the FM transponder before I continue? No? All right. I did talk a little bit about the youth initiative when I was talking about the SSTV payload as being a possible payload to fly in support of the youth initiative. There's another aspect that I'm not going to do justice to when I describe it, but it's basically a ground-based radio transmitter that students can receive on the ground, and the payload of that is going to contain a series of environmental sensors. The idea is to really give youth an opportunity to work in the STEM field, be able to build and receive actual environmental signals from payloads that are developed by us and deployed in major markets. And again, I'm not sure I'm doing that justice, but I hope, Frank, you're talking about that more tomorrow. What time? Tomorrow morning. I heard tomorrow morning. I'm going to run with that. But to that end, the volunteer who's doing that, Mr. Joseph DeVerde, is primarily taking lead on the KidSat environmental sensor, but he actually took that idea and decided to take it even further. He works in the chemical space, I'm going to say, and I'm going to get that wrong too. So all the things I have wrong, somebody can write down and email me about later. But he does work in an educational setting, working a lot with physics and or chemicals and or exciting things like that. So he has peers that he has polled about what would we actually be able to fly in our satellite that would provide real scientific value to the scientific community and add to the knowledge of our world in terms of environmental sensors. So he started polling his colleagues and began putting together a series of requirements. The words multispectral keep getting thrown about, so I kind of have a sense we're going to be flying some multispectral imaging here at some point, even recognizing we have some NOAA considerations when we start flying sensors of that nature. GPS payload is another ASCENT project that we're just spinning up that Joseph has expressed an interest, personal interest in. We had made the decision a couple of weeks ago that even though it would be interesting to fly a GPS payload on Golf T, the technical and schedule risks exceeded the potential value of that. So I immediately was willing to take that under the ASCENT program. So we are looking at building a GNSS payload that we'll be able to fly on future AMSAT satellites. You'll remember from my thruster presentation, one of the three legs of the stool we need in orbit is location information, and this will be the payload that allows us to acquire that. And last but not least, we had a volunteer, Tom Davis, who did a fantastic job of putting together the physical reaction wheel assembly, the wheels, the motors, the housings. What we don't yet have is the control electronics to spin those wheels under our command and control. Mr. Don Corrington has a wheel in his possession, has some prototype electronic hardware in his possession, and has begun working on that. Moving right along now, I will shift gears a little bit to talk about Fox Plus, which is another program, sister program to Golf. I won't spend a huge amount of time on this, but I'm happy to answer questions. Golf Plus is intended to be a faster, more rapid launch sequence to get amateur radio in space and keep it there. Launches 1 or 2 or 3 per year should not be absurd to think about, maybe even more. To do that, I had intended originally to leverage the Fox FM transponder, but as you may have heard me say, we actually had to take a step back and develop a new FM transponder, mostly because we had end-of-life parts that impacted our ability to do so. So I have now pivoted, to use that term, pivoted, to fly the linear transponder module instead. And even though we still have end-of-life parts on the LTM, and we have Leandra and Dave Hartram working very hard on that. We are slowly getting those boards manufactured. I have 3 ICR boards in my possession that are being exercised by Mike Moore, I think. And I'm preparing to assemble 3 LIHU boards any day now once I get my act together and kit the parts. And then the last piece, the transceiver piece, is the one that's probably my long pole right this second. Well, we have another volunteer whose name is escaping me, Burns, who's working on assembling the TXRX board right now. Dan Habecker? Habecker? Dan Habecker, I think, if I'm saying his last name correctly, is doing a bang-up job in terms of building the next generation TX board, which I'll be leveraging. I'm hoping that I'll be able to start manufacturing those late this year. My plan is to develop 3 prototype boards. Once any one of those works, I'm going to go ahead and build an initial production run of 5 or so boards, and I'm throwing these numbers around rather loosely, I admit. But once I start confirming that those are going to function and getting those to our partners, I keep throwing around the number of 20. I want 20 LTMs on a shelf so that I can share them with people. There will be people that correctly point out that we don't exactly have a lot of flight heritage with this particular iteration, but I share with my partners very openly that this is a low flight heritage board at this point, although we do have some experience with various aspects of it, and we should be very careful about our ground testing to make sure that we exercise it on the ground. And I'm looking at you, Dr. Fevig. AMSAT is providing that. Yeah. Oh, I'm sorry. We are commercially purchasing several components. The frame, the electrical power system, the antenna system is coming from ISI Space, as is the solar panels. There's a little bitty bracket that you can't see, but the frame, EPS, and antenna are supposed to be here this week. I'm supposed to have 2 sets of hardware showing up at my home this week. I haven't received shipping notice yet, so I'm a little suspicious it won't quite arrive, but in talking to the vendor a couple of weeks ago, it's very, very close. I'm going to show some pictures, but I'm going to move relatively quickly. Antenna, power, LIHU, but I do have a physical LIHU over here too. Talk a little bit about futures projects on the horizon. It shouldn't shock you to know that I am interested in getting thrusters in our bag of tricks. That was my whole presentation earlier. But I'm also very interested in expanding our microwave capabilities. And to that end, I have an open project right now that hasn't been funded or even really authorized. But I think I could obtain that by simply asking the board for permission, and I would get a nod to support a microwave ground station. I also like to talk about future partnerships that engineering is engaging in, because we need to continue to expand our capabilities and our reach and our scope. Dr. Ron Fevig is joining us today from University of North Dakota. We've had some very good conversations with Dr. Fevig. We are going to be partnering on the Cape 4 mission, which Nick Pugh is involved in, wherever Nick went off to. There he is. To provide an LTM platform for flight on that mission. So we're feeling real good about that. We're working closely with Dr. Fevig to figure out how to partner with what I'm going to call a university lab environment that has an ongoing presence. One of the challenges you have in a university is continued graduation of your students. It's hard to keep a consistent flow of knowledge. So by partnering with somebody like Dr. Fevig and some long-term employees and professors and grad students, we hope to be able to maintain a long-standing relationship there. I also throw out Morehead State University on this slide. We don't have anything formal, so if you're seeing this in this room or on the internet, this is not an endorsement in any way, but we did have some very positive conversations when we were out at Morehead State University for the AstroCon, and we do think there are some opportunities to partner with Morehead in terms of projects and opportunities. We have one more slide, which is being provided by Jerry here, and then I'm going to take a breath and a drink.
The last piece that I had was in regard to future opportunities, if you will. One of the things about trying to get higher in orbit is, of course, the orbital debris. There are some possibilities that are opening up as the industry opens up, and such are, for example, to be actually hosted on a platform that stays in orbit somewhere. And those missions are out there right now for various things. In that case, with regard to orbital debris, that's their key to be able to, take care of that paperwork, if you will, and we would not have to worry about it. So that is, and also in doing this, we wouldn't necessarily need an entire satellites around it. So the idea of going to the higher orbits, though, requires a little bit of thought at the bottom, depending on where we go right off, because we are going to be in those thermal and radiation environments, for example, that we're working with to try to mitigate with RTIHU and such. And so far, we've had a few opportunities come to us, but they are usually, as the industry is faster paced than our 6 full-time employees, a rather short timeline for what we can deliver, especially because we don't have anything specifically there. Oh, let's see. Actually, that's not a good slide, sorry.
That's when we're skipping.
There we go. Should we be prepared to go for that, such a thing like that? In other words, start projects for that? Heck yes. Should we have something on the shelf ready to go? And that is a question that depends on a lot of factors. LTM will lead the way on that linear transponder module to go wherever, keeping an eye out for what it does. And or another option would be that we just kind of hang out, and if something comes up, then we do something. And that would be that quicker production, for example, or maybe even something commercial in order to get a higher orbit bird before we advance there with the goal. That's all I had for now, and this is where later I think we'll have an opportunity for the engineering team members to come up, do a little talk, and you can ask them very specific questions about the various systems and such.
So, yeah, you can't tell I may have been a professor somewhere in my past, so there's no such thing as a short presentation. However, I've been generously given a few more minutes for questions, so maybe about 5 minutes. If you have any questions, please. Okay, I got 5 more minutes. Please, help me out here. There we have a question.
Yeah, Jonathan. So one question I had, one comment, I suppose, and question is the SDR-based FM transponder. Having worked through one in orbit, BY-70-1, the latency was kind of it confused the brain, which is obviously going to be a problem if we're doing any full duplex stuff in geostationary or higher orbits. But in terms of the FM transponder, are you what sort of latency do you think you can achieve with current technologies?
I'm going to pull that time-honored tradition of answering a question I know the answer to and ignoring the one I don't know the answer to. We do have some considerations to take into account on an SDR. Power requirement being the big one. They're not necessarily cheap on power. That is just one of many considerations. I'll admit I hadn't considered the processor latency in the middle of that as being an issue, so I honestly haven't investigated it, but that is something to consider going forward for sure. Other questions, please? We have another question. Hold on, sorry a second, sorry. I know.
Sorry, I'm not familiar. Can you say more about CAPE 4? You just put the acronym up there.
I can't, but will we be talking about CAPE 4 at all, Nick, at all? Okay, there will be a presentation tomorrow that mentions it. Sorry about that, I just don't know that much about it as a mission. Any other questions? We have one more. Okay, you're a volunteer, that worries me.
Yeah, I spend my day job in this industry, so I could probably come up with a lot of questions. But we're overall moving towards a lot of AI/ML stuff. Do you foresee or ever think about AMSAT getting into looking at leveraging AI/ML for future exploratory things?
Yeah. So AI and ML and that type of deep learning networks, that type of thing, is an interesting technology. Most of that artificial intelligence, machine learning. I mean, it's in the news a lot, but what it really typically means is very complex pattern matching networks is really what it turns into in practice. I can think of many opportunities where we might fly a payload on our satellite, not as a amateur radio radio payload, but as a experimental payload that might utilize that in terms of detecting of space environment, mineral effects, any number of things. So I could see leveraging it. I don't have any volunteers expressing interest, so I haven't seen a lot of activity in it right now. I have one more question if anybody would like to ask one more. Who wants to be my last question? Hold on, sorry, it's coming.
Oh, you could have heard me. With the FM transponder looking at using an SDR solution, what's the possibility of using that also as a next generation linear transponder module?
Huge, huge opportunity. In fact, that's why I'm most excited about leveraging SDR technology for the FM transponder. While my charter was originally to develop an EasySat with an FM transponder on it, I'm not able to do that right now. But I'm chartering this FM project to meet that objective, but it would really make me happy if we're able to leverage it for a variety of other modulations and capabilities, including linears and digitals and experimental payloads. So yes, that is exactly why I'm interested in doing it as an SDR at this point in time. With that, I know I'm out of time. Thank you all very, very much. I appreciate it.